And then I got another question regarding like, so what does it mean by different levels of precision? So again, when we're talking about different levels of precision, we're talking about how many decimal places are past that point in a number. So like 3.1 is less precise than 3.14 because the more digits you add after decimal places, the more precise you are when you get into the actual number. So the higher precision basically refers to how much more digits you have after the decimal place. So a more precise floating point type would just have like a bunch of decimals and like a bunch of numbers after it. So there are two additional fundamental types that exist. So again, this is something that we talked about yesterday. So void identifies the lack of any type. So if you don't have a character or an integer or a floating point or a Boolean, that is a void because there is no data type associated with it whatsoever. The other kind of fundamental data type is null PTR, which just refers to null pointer. And this goes into like pointers, which we won't really be talking about this week, and you don't really have to worry about it either. But all we mean is when we're talking about like the null pointer type is that we're basically, again, pointing to nothing. So you can think of null as nothing and a pointer as you actually pointing to something. So when you actually, this happens when you create an object, and don't worry about like what an object is, but just imagine like you are creating something, and again, that something doesn't have any value whatsoever. So for example, I was going to create like a car, okay, but my car doesn't have an actual engine. That's what a null pointer is. Like there's nothing inside of the car. There's nothing that the car is really made of. We just have like this kind of general shape or this general idea of what it's supposed to be, but it can't actually do anything. And that's the kind of null pointer that exists. You don't really have to worry about the definition. What's more important is that you understand what void is. And void basically means you're none of these things. You're not a character, you're not an integer, you're not even a decimal or like true or false. You're nothing. That's all that void means. That's more important for you guys to understand. And then again, another cool thing about C++ is that it supports fundamental types and the combination of those fundamental types. So later on, like I said, we'll be talking about strings. And strings are basically compound data types because it brings together a bunch of characters to make an actual word. So you remember how I said car, the variable type car is just basically a letter? So that letter is just A, right, for example. A string is a compound data type because it basically puts all of these characters together to create a word. So I put the character A next to L, next to L, next to a Y, then we get like Allie, right? And that's actual like word or the actual name Allie counts as a string, but the individual letters counts as a fundamental data type, which is the character. So I hope that difference makes it more clear. What's the difference between like a compound data type, which is just basically bringing together all these fundamental data types. And so pointers, like I said, will be talked about, like definitely not in this camp, but if you go into more advanced like C++ classes, then yes, you will be talking about pointers. And then compound data types refer to like strings, and you will be talking about strings like later on this week. So just as a repeat, compound data types are the combination of fundamental data types. So for example, character counts as a fundamental data type because we're only referring to like one letter. And so when we're doing compounding, like that one letter together to create a string of sentences, we get a string. So that's all. It's just an example, basically. A compound data type is just the combination of multiple fundamental types. Did that make more sense? Okay, so any questions so far? So a fundamental data type is everything we've been talking about just now. Characters, booleans, double, integer, like float and integer. So that like entire table that you had, that's a fundamental data type. The table I told you not to write down. And then the information in the previous slide, those were all fundamental data types. So they're fundamental because they're the building blocks of basically everything. They're just letters, they're just numbers. That's the fundamental basis of you creating anything. Okay, cool. So next slide. Now we're going to talk about declarations. So how do you actually create these variables, and how do you actually make them? So C++ is a strongly typed language and requires every variable to be declared with its type before its first use. So this informs the compiler that there's a certain size of memory that must be reserved for this variable even before you initialize it. And by initializing, all we mean is actually providing that variable with a value. So this slide basically shows an example of how you're supposed to declare a new variable in C++. So again, all we mean by declaring something is just by telling our computer, hey, this variable exists. So for example, int, float, and you can't see the thing at the bottom, but int and float and double are all three different types of fundamental data types. Int is an integer, float and double are floating variable types. And these names that we provided, a, my number, another number, these are valid identifiers that we defined. So I defined an integer as a. I defined as a float as my number. We don't actually know what a equals, right? We don't know what the value of a is. But what we're telling our computer is that there is some sort of variable that's going to exist, and we're going to create it and set it to a value later. But for now, it exists on our computer as just a variable, just so that it can store a memory for it. Just say hey, there's this little variable that we have. It's an integer, so it's probably going to be 4 bits of memory that you have to allocate for space. We don't know what that value is going to be yet until the programmer tells us, but for now, we're creating a space for the variable to occupy later on when we actually define what the variable is equal to. But for now, all we're doing is creating that space. Does this explanation make sense? If no, completely tell me. Just tell me, it's fine. If it doesn't. Okay, so another way that you can think about this is, let's think about actually in a real life circumstance, right? So I have 5 apples, okay? And so what I want to do is basically put all my apples into a basket, okay? And what I'm going to do with that basket is label it as apples, okay? But even before I put my 5 apples into that basket, I already have a space where all my apples are going to be inside. That's all you're doing right now. You're creating that space to store something. So this declaration of int, float, and double is storing a space for you to put in those variables, put in those values later on. So you don't have to worry about the 5 apples yet. For now, we just have our basket, and we're labeling that basket as apples. You can label the basket whatever you want. If, for example, you love apples and you think it's the best fruit ever, you could just say best fruit ever, and you're labeling your basket as best fruit ever. You can even label it as the worst fruit ever. It doesn't matter. You get to define what the basket is, what that variable is as the programmer. But you don't have to worry yet about what's inside the basket. We're just going to say it's apples for now. Does that make more sense? Okay, cool. Okay, cool. So I'm going to share my other screen, and I'm going to share the replit to show you how you actually declare. Yeah, okay, let's do the same thing. How you're supposed to declare it. So here you see I have my hashtag include IOStream, okay? This is the same hello world program that we've been dealing with all of yesterday. All I'm going to do is after this hashtag include IOStream, I'm writing int a. That's it. That's all I'm doing. And nothing different should happen. You see here, we printed out hello world. I'm a C++ programmer. All of this was already there beforehand. Nothing changed. All I did was just declare the variable right now, because we didn't do anything to that variable yet. It's me taking out my basket. That's all. I'm just taking out my basket. Nothing happens. The program doesn't do anything. The program should definitely not crash. But I want you guys to get creative with it. So instead of saying int a, say int here is a crazy number. You know? You can name it basically anything you want. This is your name. And you can name that however you want to name it. It doesn't matter. but you need to follow those like valid identifier rules that we talked about. So you shouldn't get like too crazy, but it's up to your full discretion. And there are other different data types too. There's int, there's double, there's car, there's the bool, actually bool, yeah. Yeah, and again, I can write all of these different data types, and when I run it, nothing's going to happen. Nothing changed because we're not printing out anything, we're not doing any operation, we're just declaring our baskets. We're just creating the stuff, creating the space available for us to actually do something. So now let's actually go into the meat of it and actually let's do stuff. So great, we declared a variable, woohoo, we did nothing. But let's actually start doing stuff. So if we're declaring more than one variable, this is just like a side note, you can basically put them all together into one line instead of like separating it out. So the reason why we can do that is because we're using the same identifier each time. So int a comma b comma c is the exact same thing as int a semicolon, a separate line, int b semicolon, a separate line, int c semicolon. The only reason why you might want to use the first option instead of the last is just because you want to save more space, or you're like a lazy writer and you don't want to have to write like more lines of code. So that's all. This is just like a quick note. This is more of a style thing than an actual syntax thing, just to show you like it's possible. Okay, now actually to creating stuff. So initialization is what happens after declaration. So when the variables in the example above are declared, they have an undetermined value. We didn't set our integers into anything. We didn't put anything inside of our baskets. We just made the space for it. So they don't have a value until they're assigned a value. So it's possible for a variable to have a specific value from the moment it is declared, and this is called initialization. So in C++, there are 3 ways to initialize variables. So there's something called C-like initialization, because it's inherited from the C language. So we're learning C++ right now, but there's so many languages before it, like C, Fortran, COBOL. You don't have to worry about it. You don't even have to worry about this name. It's just telling you that one way you can identify or you can initialize a variable is by saying type identifier equals initial value. So the example that shows after this goes away, is int x equals 0. So what we did just now is we defined that we have our basket that's an integer value, right? And we named our basket x. So we're going to put some amount of things inside of our basket, but we don't know how much yet. But now what we did was by putting the 0 equals 0, we said nothing. We're going to put nothing inside of our basket. So that's what initialization does. It gives it some sort of value. So declaration just creates the space. Initialization gives a value to put into that space. So I'm going to get out of this quickly. Sorry for anyone who's taking notes, but I just actually want to show you what the replit looks like, because I feel like a lot of times showing the code makes a lot more sense than just reading it off of a slide. So here, for example, I defined an integer called a, okay? This counts as a declaration because I created a space called a. Now what I'm doing is initializing it because I'm saying that that space a is now going to equal to 5. So I'm going to put 5 things into that space. I'm going to put 5 things into my basket. And what kinds of things? Well, I'm putting numbers because it's an integer, right? So like you're going to put 5 apples or whatever. You're not going to put 5.4 apples because it's not double. It's an integer type. But again, if you run this code, nothing's going to be happening because all we did is just we defined some value for it. We still didn't do any operation. We still didn't output anything into our code, but we created a space. Like the computer itself is actually just creating a space and putting a value, assigning a value to it. So that's all that is.